Okay, the recording started. As I said, today is mostly theory. It's the while loop that will be starting. Anybody know anything about while loop? It's a new term. You know? What about Ben? Ben, you heard about while loop?
I've heard of it before, but I haven't ever done it.
You have confidence with the for loop?
Yeah, a little bit. I, I, I honestly I think it was easier than using different functions. I think that's
Oh, user different function is difficult.
yeah, I think that was
For loop is much easier, much easier. But while loop is difficult. Not like user different function level difficult, but it is kind of little difficult than the for loop. What is the difference between while and for? First of all, it's just the syntax difference, and the main goal is a little bit different as well. The benefit of the for loop, while loop, let's start with that. Benefit of the while loop is you don't have to define uh, how many times the loop is gonna run. You're gonna rather put a condition. If the condition matches, the loop is gonna end. Other than that, the loop is gonna continuously run. Unless in the for loop, what do you do? In for loop, you define some final value or max value up until that many times the loop is gonna run. You've seen that, right? But in while loop, you're gonna put a condition when you're gonna start writing the loop. You're gonna say like while that condition, then write all the codes and everything, and then end the program, and then this program is gonna run. Even if it have to run like million times, billion times, trillion times, or two times, one time, okay, no time. It all depends on the condition. Unless the condition matches, the thing will gonna run continuously. There is a negative side. There's too many negative sides. Actually, two negative sides for the while loop. There's a benefit, right? Benefit is, say like you don't know how many times the loop needs to be run, right? Like the thing that Ethan was showing it to me, like the harmonic series, right? I mean, it says like go up until infinity. Now infinity, nobody knows what is infinity, right? How many times it needs to be run? You don't know. But if you're gonna put a condition that okay, when this condition met, stop. Otherwise, keep running. So that is while loop benefit. Now we have seen in for loop the same thing. Same thing we've seen, right? Remember how it happened? In for loop, you define initially for certain big number that many times it needs to be run, but inside you put a condition like by if and say in sine or cosine Maclaurin series. Remember in one class, on Maclaurin series we put a condition like if the convergence is less than this value, then stop. Even if inside the for loop. So that's the extra step that you got to do in for loop, right? Like you got to put this if statement, right? But in while loop you don't have to do that. You just put the condition at the beginning and tell the loop to run continuously until that condition matches. Excuse me, makes sense? Understand? So that's the intro. Now you'll be seeing mostly the notes because this is the new thing that we are running, right? Excuse me. So let's start. So while loop, what? Part 1, there are 4 parts for while loop, right? The title description should be the the typing is a little slow. No, it's a little smaller, right? You guys can see better now. All right, the title description should be we are introducing to while loop and the main code, right? And you know, main code we do this thing CLC clear close all, right? The usual stuff. And then let me put some reminder for all loops, right? In general, all loop consist of 5 basic things. We did learn it before, right? What are those? So number 1, a parameter to be used in determining whether or not to end the loop. Okay, so there's the first one. A parameter, right, needs to be used to determining whether or not to end the loop, right? Remember, you initialize the parameter, you define some values of the parameter, those sort of thing. All right, so then you initialize the parameter, obviously. So initialize the parameter. So then you have to change the parameter inside the loop, right? A way to change the parameter each time through the loop. So let me finish all 5 of them. I'll talk in detail again with everything. So number 4 would be a comparison using the parameter to a criteria used to decide when to end the loop. And number 5, calculation or operations to do inside the loop. All right. Those are the 5 steps. Take your notes. Then I'll talk. I mean, we did talk about this during the for loop. See how much you remember. Okay. Both of you typed it, right? You can use some more time. All right. So, all right. For the for loop, I'll just talk about the basic of the for loop, and we'll try to compare with just 5 minutes, right? For loop, how do we do? We start with I equal 1 colon some final value, right? That's what they're saying. Initialize the parameter, right? Initialize the parameter, okay? And you're going to define a parameter. Those are first 2 points. Okay. Then it's saying you're going to put a criteria. You're going to put a criteria when to end the loop. Now in for loop, we put a criteria by assigning a max number, right? Like up to that number, the loop is going to run. Remember, sometimes we define by a matrix like length that matrix, right? How many elements in the matrix? Either way, right? So that's the for loop. In while loop, however, the criteria would be the condition. I did talk about it, right? We haven't seen it. We'll see it. All right. So finally, the operations, that whatever will happen inside the loop, right? It's same as like for loop and while loop, right? Operation means like the mathematical equation or whatever that you're writing that you'd like to explore every time the loop will gonna run. Okay. So those are the 5 elements for the for loop or while loop, or in other words, in generalize the loop. Okay. All right. So then the while loop. Let's talk about that. So while loop, so the definition, I guess, the definition would be a while loop is just another type of repetition structure, just like for loop, right? All right. So they have the same 5 basic parse as for loops. Okay, however, we have more control, as I keep saying, right? We can put the condition, however, more control over those parts, right? Why? Because they are not simply done for us as in a for loop. Okay, because we can put a condition, bottom line. What is the other benefit? By using the while loop, we can do more complex thing. So we can do more complex things sometimes, not always, with while loop, or we can mask them up more and make okay, and make infinite loops or loops that don't function. All right, as the underlying message here is, like, you know, we can deal with complex matters by putting conditions, okay, and it is far better, far superior than for loop in that aspect. If you don't know how long it needs to be run, how many times the loop needs to be run, or if you're dealing with the infinite condition. Let's do it example, but before that, let me deal with the helpful tools. If you get stuck, that's very important. Remember, Ethan, I was talking about, like, you know, in a while loop, if you're dealing with the infinite series, right, and if you have like that infinite series running continuously, right, then what to do? So the loop is running infinitely, and you can type anything again and then run it again, and then, you know, you kind of literally stuck, you have to restart the computer. No, you can use this control C, okay, and then it will going to stop. So that's the goal. It will going to stop when the loop is not ending. All right, so let me put that in comment here. So if you get stuck, okay, in an infinite loop, type control plus C in the command window, to end the process. So let's deal with the example one. A simple while loop, okay. Number one, k equal k plus 1. That was so important. So k equal, let's initialize k equal 1 first, okay, and then let me put a note here. So this is our loop parameter, commonly referred to as the loop counter. All right, so we almost always need to initialize the loop parameter or in other words loop counter for while loop. Now as I said, today's class is mostly typing on notes rather than the actual code. So what we are doing here, first of all, we are dealing with a simple while loop where we are keep adding some value of k while the while loop is running with the condition of k is less than 5. Okay, so the value of k would be keep increasing every time the while loop is going to run from 1 to 2 to 3 to 4 and up until the 5 it will going to keep running. Does it make sense? And you will keep adding that value. So that's the thing that we're doing. So the first thing is, like, obviously you got to initialize the parameter, right? So as it says here, it is our loop parameter or loop counter k that we assign it as a value with 1. So once you're done with that, all the details that you are done, then you would like to write this note while k, and the condition that you are trying to put, k is less than 5, right? And let me put a note here. So you are doing a comparison to criteria used to end the loop. Okay, that's one of the steps, right? When to end the loop. And then you're writing, say, like k equal k plus 1, and then you are saying you are increasing the loop parameter, in other words loop counter. Remember, loop counter is a keyword. Okay, by value by 1, okay, each time through the loop. Okay, and then you're gonna simply end this while loop. Okay, and you can run it and see what is the value of the k that you found. It's the first while loop. So week 11 lecture 2, and save it. You're gonna run it and you're gonna type the value of the k. You'll be seeing the k value is 4. All right, so that means this while loop is running 4 times, right? When the k value less than 5, it stops and it won't be running anymore. Okay, so basically one very important thing that I'd like to highlight, when the while loop you have a condition, every time the loop is going to run, what is happening here? Every time the loop is going to run, it is going to verify the condition. If the condition is true, that is, it assigns the value 1. True means 1, false means 0. Okay, if it is true, that means the condition that what I put here on this, then it is going to keep running. If it's false or 0, then it is going to stop. Sounds silly, like no, true and false, 1 and 0, but you'd be seeing in later class, like, one would be dealing with advanced while loop options, then this would be becoming important. Why 1 and 0 for true and false? Okay, any question?
Um,
Is it running?
yeah. What do I type in now? Do I type anything like that?
Oh no, you can type k and see what is the value of the k. Should be seeing 4, because when the k value is less than 5, it will stop running, right?
It says K equal 5.
It does. Okay, I gotta check. Oh yeah, k should be 5. I'm sorry, because k equal to k plus 1, yeah, k should be 5, I'm sorry. Because, on the program, I did write k equal to k plus 1.
Yeah.
So when the k value is 4, the updated value is 5, because 4 plus 1 is 5. And then next time it runs, like it's already 5, so it will gonna stop running, and it won't be running anymore. All right, so then the true and false thing that I was saying. So this way a while loop works is, so the idea is as long as the condition matches, it does run. If the condition doesn't match, it doesn't run. So while true or 1, for example, the loop runs. While false or 0, for example, the loop ends. Okay. All right, so example number 2. So incorporate a calculation into our loop. So what calculation I'm talking? Say like clear all and CLC. You'd like to clear everything from the screen, right? Clear all the variable that you had before on the example 1, and you would like to start fresh from here. Okay, so that's why you're doing this clear all and CLC again for this example number 2. Okay, and then you're defining k again. Now it doesn't need to be clear all and everything. You could have done like with the I or j or other variable element, it doesn't matter, but just doing something fresh. Okay, so k equal to 1, and then what you're doing here, basically you are initialize the loop counter. All right, and then you are defining a matrix element A1. The first element of matrix capital A is 5, and you'd like to put the nodes here. So that's the, so provide the first value of matrix A, right? Matrix A, so that we are building in the loop. Okay, so basically we are creating a matrix by using a while loop. That's what we're doing in the second example. Okay, and the first element of the matrix is A1, which is 5, the value that you assigned, right? And you initialize a variable k equal to 1, okay, before starting the while loop. So you would be using as a loop counter. K is a loop counter. Okay, when I'm saying loop counter, remember in for loop you don't have to do the loop counter, because you had, remember at the beginning, for I equal to 1 colon some value, right? So it does count automatically. In while loop you don't have something like that. So you got to initialize that before the while loop, and then inside the while loop you got to add it just like example 1, k equal to k plus 1, or if you initialize this by I, then I equal to 1 before the while loop, then I equal to I plus 1. That way you gotta do the loop counter, so that loop can progress. Okay. All right, so moving on. So then while loop, the actual while loop, right? While ak is less than 1000. What is it? What is it I'm saying? Saying like, I'm defining a matrix A, capital A, where the first element before the while loop I defined it already 5, right? And every time the while loop is going to run, I'm going to assign a new value of that matrix element, right? And I was saying like, okay, do it until the value of that element of a matrix is less than 1000. Now, obviously, I haven't quite shown you what would be the equation for this element A. Equation means how you can assign the value of A, right? My first value I assigned, but the other values needs to be assigned inside the while loop. Okay, so I must have put a equation or something for the element of the A. Okay, so like A equal to k multiplied 2 k square, whatever, right? Something with the k. So let's do that. Once you understand that, let me put a note here. What is that you're writing here? AK is less than 1000. So basically you are saying as long as kth value means what? You understand that, right? The k is the element, right? Element of the A matrix. The kth value of capital A is the A matrix is less than 1000. That's what it meant. Okay, and then you would like to define obviously the A matrix, but before you do that, you do the loop counter, right? Increase the k value just like last problem. So I'd like to put a note here. So you are increasing the loop counter, and that's the must for every while loop. Okay, blindly you can do it. Initialize the parameter k or I or j or something, and inside the while loop you keep adding a value of 1, so the loop can progress forward. Okay, 1 or 2 or whatever you feel like you'd like to move on. So that's what's so important. AK is the element of the A matrix, needs to be defined by some equation. Let's deal with this way, like 5 to the power k. So that's how you're defining the AK, and that will gonna calculate a new value of A. All right, and then you're going to end the while loop. So that's it. That's about the while loop, right? And then now when you're going to run this, what will happen? You'll have a matrix created for you, right? You see, run it, and you see you're going to have a matrix. You're going to create it. You won't be probably seeing it in the command window. You have to type A to see it. Now, interesting thing is for the A matrix, what is the highest element value?
3,000.
Okay. Now, here's the problem. I did say this to less than 1000. What is the second highest value?
600.
That's the catch. You see what happened back here? After the A matrix element value 600 something, okay, this while loop we're going to see, okay, the value is less than 1000. I can run it one more time. And then it is running it one more time, 5 to the power, and then you have this new value came up, and then when it is going to come back again, look at the value of the A, right, with this new element of 3000 something, and you see, oh, now it's less than 1000. So it's more than 1000. I can stop. I won't be running it anymore. But you already have the damage done. The last limit is more than 1000. It makes sense? That's why you're seeing the last limit more than 1000. Is there a way around how to escape the last one? Yeah, definitely. You can do something with the program, right, with the A matrix, right, and then you will be getting it less the last value deleted or do something about it. But that's the reason you are getting it. Okay. All right. So, any question? All right. So then I have some notes here. Okay, a lot of notes. About this 1000 thing that I was explaining. Let me put them here. So what is happening? This loop continues to run until the kth value of A is greater than or equal to 1000, right? Even though I put the condition less than 1000, but it will going to run until it's greater than or equal to 1000, right? Why? Because the last time through the loop A4 is equal 625, right? So it enters the loop does the calculations, and then you have this A5 become 3125. Now it cannot go back into the loop keeps to the end. You see, when it sees the values is more than 3000 1000, and it will gonna go back to the while loop and see the condition doesn't matter anymore, so it will gonna stop. So that's the criteria to stop the problem. So I have another example after you're done with this. I was talking about the counter, right? So far I had this k as used as a counter, right? The loop counter, they say, right? Every time inside the loop I had to keep increasing the value of the k by k plus 1, right? Now what if you don't have a loop counter? What could be the issue that you face? Okay, that's what we're going to explore now. So example number 3. So while loop without a counter. So let me start with that. Say like x, the input function. Everybody know the input function, right? You've used it all the time. You're asking the user to give an input value, a numerical value. By doing it, please enter a positive value of x, and then you can put a new line, but I know input function doesn't take new line /n in Octave, but MATLAB does. Okay, and then you are writing a while loop while x, that value that you are getting it from the user, is less than 0. If the value is less than 0, then what will happen? Then the screen will gonna get cleared, and then you're gonna get a message which is x equal again input, and then you would be asking the same thing to the user. So like, please enter a positive value of the x. Okay, what is really happening here? Okay, and you can do f print f, because this, unfortunately, this thing, the /n doesn't work in input function in Octave, but in MATLAB it does. But fprintf /n, you can put it here, right? So the cursor will gonna every time move to the next line. You can do the same thing here. All right, so then you're gonna simply end this. What will happen here when you're gonna run this? You see, you are asking the user to put a value of x, to put a positive value of x, but user may put anything in their wish, okay, negative or positive as their wish. So if they put a negative value, then this while loop will going to trip off. Oh, the x is now negative, so run it again. Ask the user again, unless until the user give a positive value, we're going to keep asking infinitely, right? So try to see if it works. You see the fprintf /n for new line, right? I have to put it here anyway, because this input function doesn't work in Octave. The / doesn't work in Octave. So save, run. Say I put a positive value 2, that it did add. You see, give me the x value. But if I'm gonna go here, then run it again, or I put a negative value of -2, it keep asking unless until I have a value, no matter how many times I put. If I have a negative, it will gonna keep asking. If you understand it question and give a right answer, then it stops. Okay, isn't it interesting? That's what the benefit of the while loop. Benefit excited? The while loop, right? It can run for infinite amount of time. Okay, and then I do have the final example. And again, as I'm saying, our main goal today is to learn the basic of while loop. Okay, so very elementary stuff. We do have 3 more classes left, right, for the while loop. So many things to learn. Oh yeah, I did talk about it. In the next week there is no Wednesday class, right? So I gotta probably curtail the while loop a little shorter. Means like 2 classes combined in 1 class. The next class, Monday class, would be a little longer, because I would like to do at least two class worth of material in 1 class. Okay, it is very easily possible with a 3 people class. It's not an issue at all. Okay. So example number 4. So using a while loop to count the number of items satisfying some criteria. So this is the first time you'll be seeing it, Randy. So what is Randy? Randy is a function to generate the random number of values, right? Random number of values. So Randy, you're going to assign, say, like Randy 20 comma 1. All right, what does it mean? You obviously want to put a semicolon because 20 times it's going to show you different values. So you're determining how many matrix value to create.
What is Randy mean?
Randy is a random number generator.
Oh.
Okay, we'll be seeing it shortly. So then you're defining x, another x, capital X, small x, doesn't matter, whatever we're going to define. So Randy again, and then you have this 50 comma n comma 1. So it will gonna create matrix of pseudo random integers. Okay, that's what the Randy does. Okay, whatever reason this parenthesis was misplaced. Okay, then you'd like to initialize, say like I equal 1. I mean, you can do k again like before, I, j, k, l, m, n, o, p, doesn't really matter, whatever way you want to define. So basically you are initializing, right? Initializing the loop counter. Okay, and then you'd like to use a different variable called count as 0, and you are saying this is initialize the item counter. So that's now it's still different, right? You're counting the loop by doing I equal 1 and counting the item by doing count equal to 0. And then is the final thing, right? While loop. While I, that's the loop counter, you're saying less than or equal length of this X matrix. That's also important, right? What is length of X matrix refers to? We have done it before, right? Ben, you remember what is the length function do? It gives you the number of elements in a matrix, right? So this one says like, okay, while I is less than this length function. Now you got to understand this I is the loop counter, and you would be increasing the value of the I inside the loop, just like for k, right? In the first example, remember, right? All right, so you'll be doing that, and then let me put a note here. So this is the loop until we run out of items in X. Okay, run out of items in X, and then you'd like to use this time little complex thing. If X, this X matrix, I, the element of the X matrix, is greater than or equal 25, there's some numbers that I'm doing it. I'm checking if the ith item in X matrix is equal or greater than 25, right? That's the condition. Then I am using this count item counter, count equal count plus 1. Otherwise I won't be counting it, right? You know, remember the X is a random function. I use the random function, right? Right? The X is a random function. So I have like so many values created under X. And this n, capital N, is also a random function, which is part of X, right? Out of all those random numbers that created, I don't know how many of them is more than 25. 25 is a number, it could be any number that you can assign. Okay? How many of them is above the certain value? So I'd like to see how many of them are above the certain value. You understand that? So the random numbers could have any number, right? 1, 2, 3, 1000, 1,000,000, right? Like so many numbers of random. How many of them is more than 25? So that's the count. See the count variable came in play. Yes, is the counter item counter. Item counter means how many times it is more than 25. That's the item counter. Okay. But the I is the loop counter. So you gotta still do I equal to I plus 1. But this count only we're gonna add a value when the value of the X matrix is more than 25. Because X matrix does have probably 20 elements, right? 200 elements, 2000 elements, whatever it is, right? Out of all those elements, not necessarily everything is more than 25 because it's randomly generated. We don't know what is more than 25, what is less than 25.
Doesn't it have to be less than 50 too? Because you put the random was 50 and 1?
No. That is like the number of elements. So that 50, comma n, comma 1 means you are creating a matrix where number of rows, number of columns. Okay, so that's something.
Okay.
But this value that we're gonna get created inside, it's gonna be completely random. It could be a million, trillion, billion, nano. I don't know. I mean, it could be. It is random, not the nano. It would be an integer value. So integer doesn't go trillion or billion, right? So usually it has a value range. But I was saying like it could be like 5, 10, 20, 25, 25,000, whatever, right? So the value could wildly range anywhere. So that's why anytime it's more than that value of 25, you count it, okay? And then obviously don't fall in the trap of AND if. Just finish it by AND, okay?
Why does it automatically track?
It does. It feels like you have more to say. You have more conditions. If you have an AND if, then you're gonna put another conditions, write another descriptions, and then keep going on as if like we had an example in class. The grades can be only like A or fail, pass or fail. It could be A, B plus, B minus, B, C, D. So different conditions, right? You gotta keep and if this condition. If the student's grade is 82, 89, then he get B. If the student's condition is like 72, 79, then she gets C. So something like this. So that's the reason we have the and if kept coming. And then we are almost at the end. So the final thing that we'd like to do, obviously, the loop counter. So don't ever forget with the loop counter while you are dealing with the while loop. I emphasize that because this is what controls the while loop. Okay, in for loop you don't have to do it, but while loop you must. Otherwise, the loop will not gonna run, right? Increment the loop counter each time through the loop. Now it's not 100% true, partially true, because in the previous example you see we didn't have the loop counter because it is the obvious example, right? You've seen like unless this program doesn't get a positive value, it will gonna run anyway. But for this one, definitely you need a loop counter for sure. Once you have that, and then you'd like to display two things. Like one thing is the count, right? Another thing is the length is a new variable that you'd like to define is equal length function. Just like you'd like to see, right? How many of the element of the length, right? And I'd like to save it and run it. Now one thing that you can do, this example 3, you can comment it. What just happened here? I probably mistakenly closed it. Let's see if I had it saved. Alright, I do have it saved, so comment. That's the problem with Octave. I forgot how to make comment for a certain paragraph. Let's see if I can do that. Anyway, let me do it manually. Okay. We don't need example 3 without any condition. Okay, save it, run it. Alright, now what you'll be seeing, like the count is 12 and the length of this A matrix is 17. What does it mean? It means like the X matrix has 17 values, right? All right, if I understand, if I remember correctly, I got to see the definition of that. What is the randy function means? If I remember correctly, this 50 is refers to the max value. Okay.
That's what I was talking about.
Yeah, you were absolutely right. I'm sorry, I forgot the randy matrix. Let's see. Let's see a little bit more. The max value could be 50, right? I'm sorry, I forgot about that. But the way you can do it, like you can do help randy. See what does randy gives us. All right, so it gives us, yeah, imax. So imax mn. Okay, so imax. Return a scalar matrix of n-dimensional array whose elements are random integers in the range of 1 to imax. Okay, so that's the imax is the max value. So now depending on how many variables that you have, like see you have imax comma n, that's your first one, like the n you define that way, right? And the imax comma m comma n. So here if called with no size argument, return scalar random values. Okay, if invoked with single scalar size argument n, return a square of n by n matrix. Okay, perfect. If invoked two or more scalar integer size argument or a vector of integer return array with a given dimensions. Okay. All right. So basically. All right, so basically what it is saying here for the first n, let's try to understand the first n. On the first n, the max value could be 20, right? And 1 means what? Just one value it asks you to define, right? Okay, so one value, the n should have like one value, it should be anything less than 20. See, type capital N.
I have a question.
Yeah.
I don't know why we want to go with before when we have CSU.
Type capital N and see what the value got. It should be less than a value less than 20.
Oh,
Okay.
I didn't see it. Okay, it's all these.
Yeah. Okay. All right. So you see, Ethan, what I'm saying. So you see, the capital N value would be one single value, right? It would be anything not more than 20, and just one value, one single value. Let's say. So determine how many matrix value you want to create. And then the second one, you have the 50 comma n comma 1. That means like you have n number of row, okay, and one column, but the 50 is the maximum number. What is the capital N value called? Type capital N, someone. See 8. So if you're gonna just assign a value randomly, right? Anything 20 or less, right?
Somewhere between 20 and 1.
Yeah, yeah, got it.
No, I
It's there.
think that just gets frozen. I couldn't see it. It's not. Usually grays out when I change something.
Mm-hmm.
That could run. I don't have it. I don't know if I have it saved.
Yeah, it seems like it's frozen.
If you get caught, so if you do get caught in an infinite loop, is that what's going to happen? Is basically just going to be frozen and you're not going to be able to do anything? Like, how do you know if you're caught in an infinite loop?
Oh, yeah, he might be caught. So Control C, type Control C here in the command window.
Me?
Yeah, Control C.
I just remember, like, when in my old code bases, it would give you an error of like, hey, you're caught in an infinite loop. This will cause an infinite loop. Before I run this, are you sure this is what you want?
Seems like this one is like now acting completely weird. So why don't you close this? Try to restart it to
Yeah,
start
but I
working.
closed and it says.
Save.
it's
You
not
wanna
saved.
save, right? Everything you wanna save.
Yeah, but then I try and close it again.
Discard. Then discard. Then not that much you can do about it. Right? So force restart. You know how to do force restart. It didn't like it.
If I'm
You remember, Ethan, how to do force restart? Is it like, yeah?
What's up?
No, I have to pass it.
If I'm good, can I?
Yeah, you're good. That's the last thing that we covered.
Okay.
Okay, I'll see you. Monday is important class. I'll upload a new model. Excuse me.
Your homework to be due on Wednesday.
Yeah, something like that. Okay, so like,
Have a good one.
you
Oh, so
too.
you can't come back.
This one.
Oh, so
This one.
week 11.
So it will be out.
Oh, oh.
This one. Everything is saved here. We have this one. In MATLAB, you can just simply copy the, select this thing and right click and paste. Whatever is missing. I would restart the computer, but you can do it in MATLAB.
Yeah, that's fine. I mean, I'm pretty sure I got the code right.
Yeah,
so
that will.
it looks good now. I looked it over and it looks pretty good. Oh, wait, the only thing actually that one's supposed to be on. Now I think we're good.
Okay, restart the computer.
Alright, so that's it. That's it from me today.
Right.
Thank you.
Hey.